Just for the folks that are coming up that you haven't heard speak yet today, first one is Brian Smith. Brian is my colleague at Gannett Fleming. He works in a division called Geodecisions, and he is the Vice President of Commercial Solutions. He's really spearheading most of our work in augmented and virtual reality, deep learning, machine learning, edge computing, and all the things that kind of correlate to those. And then Barry here is a member of the, he's a director, right, of transportation?
It's just a global executive.
Global executive for Cisco, working in the transportation business line. He is also a part of the board of directors for the newly formed Automated Vehicle Coalition. So Brian and Barry were the ones you haven't heard from yet today, so I wanted to just introduce them briefly.
Yeah, the only problem is that all the questions are going to come from Barry. Now, he has a lot of original ideas and thoughts, so by putting you there, we have to make sure that you ask those questions to the rest of the people. But really, it's all about, like Dr. Anderson said in the morning, it's about engineering and marketing. So I don't know if somebody's as old as I am. If you recall back in the 80s and before, there used to be electric vehicles in England. So the culture was milk bottles. So back in 1900, 1920, 1930, up till 1980, the milk truck used to come, start his round at 5 o'clock in the morning, and he used to go around the city all day long on one battery charge. And today, we need $100,000 for a car with a battery that can last a day. So things were there, but it's the engineering and marketing part of it. So with that, I think I'll let the audience ask questions.
Well, how about while we're whetting the appetite of the audience, why don't you guys just a minute or two, just observations on the day today? Certainly, there's other conferences like this one that have taken place, but what's something that stands out in your mind from today that this group needs to be talking about when they go to their next conference or engage in their next set of projects? So start with Barry and go down the line. Then hopefully by then I find some brave souls back here that make eye contact so they can ask questions.
So first of all, I think just getting started is the big piece. Diving in and realizing that this is probably the biggest single transition that's going to happen in your lifetime. This is bigger than the internet. And I work for a company that helped build the internet, and it's going to be bigger. And in that, realizing that it's going to take a huge ecosystem of private corporations. We cannot rely, you heard it this morning, we cannot rely just on our state and local or our federal partners. This has to be all of us rolling up our sleeves and building this.
I'll just use this one. You're going to pass that down. I have a microphone in my pocket. So my take on it is that it's moving extremely fast, kind of like what Gary said here. So don't think short-sighted, think big picture. There's a lot of information that's going to be pushed out. Kind of what Andrew talked about earlier. There's a lot of data that's going to be out there. How do we get through the minutia of the bad data into meaningful information and get that distributed out to your organizations and your cities and people that need it? So that would be my suggestion. Just think big.
I'm mic'd up. So the takeaway from today is just a reinforcement of what I already believe to be true, and that's having these discussions and talking to companies that you may not deal with all the time, but who are important to this industry to move closer to partnering on projects or sharing ideas. And that was really what today was about, and just, so a reinforcement of what I had anticipated.
Yeah, for me, it's exactly the same thing. It's definitely get started. It is really good to see, lots of initiatives, happening in different areas, because from a technology standpoint, I mean, generally, I've known about sort of this super fast pace of technology, probably about 15 years ago. Came across a couple books. I don't know if anyone's familiar with Ray Kurzweil, but back in 2006, he wrote a book called The Singularity is Near, and he talks about that. Basically this explosion in the speed of how things are happening. And it's funny, he made a lot of predictions about when things were going to start happening and start really taking off. And they're happening quicker than that. So even, before there was talk about, fully autonomous vehicles, prediction was, 5-8 years out, and it's happening in 2 or 3. So, even if you extrapolate that advance in speed, it's really imperative that everyone, gets on the same page and starts working together, because there are so many challenges, as this, technology can get away from us. We experienced that, even with, say, government, mobile phones kind of, there were none. And then next thing you know, everybody had them and wanted them to connect to everything. So, getting out in front of these technologies as best you can is extremely important. And it's, great to see that everyone's doing that, both, private, government, and engineers, right? So
I think I'd like to see a whole lot more people at a conference from a lot of different backgrounds and being able to talk and get different perspectives. And I think we've seen some of that today. But to me, that's very exciting. It was when we have a lot of folks interested in the same topic and they look at it from a different perspective, and it opens up our minds to new ideas. And to me, that's probably my biggest thing that I'm, you heard me kind of push that. That is something, and it's people. And it's always going to come down to people. And I just remember a technology failure was moving technology into the hospitals. And they asked the doctors to input information, and it didn't work. Didn't work because they put the one computer, right by the nurse's station. And the doctors didn't want to have the nurses watch them fumble around on the keyboard. And when they put that darn keyboard, that computer into a special room that only doctors went in, it went just fine. And there are many, many, many things of people over and over again. And the other thing, I guess my biggest takeaway is I believe fully in the private sector. And that's the great innovations are going to come from the private sector. And we're kind of dabbling between private sector and government because we're dealing with civil, and a lot of things in civil come out of government. But I think we need to be pushing harder and connecting better with private sector.
And also diversity in private sector. I don't think it's just engineering. I had a conversation with a gentleman here from here in Phoenix, and he deals with the wireless systems. And so I don't know if you're an engineer or not, but your role is important. So it's not just engineering; it's also marketing, like Arun mentioned, and it's getting that message out, and it's data analysts. It's all kinds of variety of backgrounds that is needed for this industry, really.
Questions, comments, expressions of optimism? Anybody?
I know I had a conversation with Barry and Brian about data and their view of data and how important the role is. Do you mind if I ask a question to them? Okay, all right.
I can't wait to hear this one.
I just had a comment.
Okay.
You're on.
What data? What question?
Well, we were talking about data and how important the role of data is in moving forward.
I can set context for you, probably. Sure. So,
Here you
do I need that? Okay. Normally I'm the big mouth, so I don't. So if you think about a vehicle today, and that's sort of where we're baselining everything, a vehicle today that is connected with an LTE connection generates about 10 gigabytes a day. Not remarkable amounts of data. Your cell plan can handle that just fine because you use that much data or close to that much data when you start streaming videos, right? And you'll hear lots of numbers up into the terabytes a day. When you hear 7 to 10 terabytes a day, that's a test vehicle in full fidelity. That means some engineer is saying, no, I don't want to lose 1 byte, right? That's not what we're really going to generate out of these vehicles in real time. So it's going to be somewhere between the 10 gigabits we are today and the 7 to 10 terabytes you hear about. My guess is more like in the 100 gigabits per day type of consumption. So from a networking perspective, it's manageable. But from a back office and a infrastructure perspective, it's not manageable, right? When you start talking about 100 million vehicles in the United States and 100 gigabits of data every day, that's just raw. We need to start to manage it. That tee up pretty well.
Yeah, sure. I mean, I think if you have to look at a couple different things with this. Going off of what Andrew kind of talked about towards the end of his talk, this concept of edge computing. From my perspective, let the vehicle collect as much data as possible. But on that computer, on the machine, let's make sure that we pull the information out of it that's relevant to the vehicles behind it, relevant to the smart city that it goes into, relevant to whatever. Okay, we can collect and collect and collect, but we don't want to just regurgitate that back out. So the importance of edge computing is going to be it's just kind of something that I don't think we come to a realization about at this point in time. One of the things that I meant to say, Eric, during my earlier discussion is we concentrate on connected and automated vehicles. And the first thing everybody thinks of with connected and automated vehicle is a ground vehicle, okay? I promise you that the next frontier of transportation is low altitude flying vehicles. Plain and simply put, it's there. I was able to attend the Uber Elevate conference this year, and when I say it's there, it's in test mode. They're flying these things. Uber has a goal of 2020 and 2023 for full production. That's not, I mean, I'll be, not to show my age, but I'll be 48 in 2023. I won't even be 50 yet. It's not that far away.
Wait, so that means I get my flying car?
Yeah.
Okay.
Yeah. And so once you start looking at that, adding that capability to it with the LiDAR, the aerial imagery, the drone to map capability, that type of stuff, now we also have this really cool capability that looks at 3D modeling. We look at 3D airways. We look at a lot of different functional things that people might be looking at me saying, that's just Jetson stuff. Yeah, you're right. It is just Jetson stuff. But that Jetson stuff's going to happen before we all perish. So just keep those things in mind.
Right, actually, wasn't my original comment, but to build on that, the aviation industry has been slow to change over the years because it's so heavily regulated, right? Yep. So it takes a long time to make a change. But you'll see even they've gone down that route, right? Now the ADS-B initiative now, it's what, next year or 2 years from now, all even light aircraft are going to have ADS-B. So it's not the airplane being watched from the ground, it's the airplanes talking to each other now, right? That's the whole point. So yeah, it's going to be, everybody's going to be a part of that picture and have part of that common operating picture. But if we want to write that stuff down, the network is going to be important, because where are we going to send it? Where are we going to?
Well, yeah, I mean,
how are we going to get it there?
Yeah. I mean,
right, exactly.
Like, this is why this guy's going to be so rich.
You
in
have
the
some
next
work
10
to do,
years.
right? You have some work to do to haul all those bits around. The comment that I was going to make, which it kind of, there were some bookends there from Dr. Anderson and from Lori, which is the human factors, right? Which is very interesting to me because I am an engineer, so I spent an awful lot of years not worrying about human factors. I cared about machines, right? Making the machine work was what I did. Other people did user interfaces and things like that. Now, because I'm also a teacher as opposed to just being an engineer, I worry more about the human factors, and especially if I'm designing curricula and things, I have to be able to get these ideas across to people who may be resistant to them, right? I have adult students. And so I was very interested to see the things that you were talking about, for example, with the context switching. We have an automatic vehicle. We have a vehicle under autopilot or some other kind of automated assistance. And then all of a sudden, that person now has to take over and do something. And we talked a little bit, I think, at the break about the incident in Arizona, where the pedestrian was killed, and when people would say, well, they should have been able to see that, or a human driver should have been able to avoid that accident. And the other side of that coin is, even if that human driver had been paying attention and the car gave control back, they wouldn't have context switched fast enough to be able to do that. So that was an interesting thing that went from your presentation for me that sort of confirms that idea, right? Is we have work to do. Anecdotally speaking, I was a better driver before I had a GPS, right? I used to know where stuff was. now, I go somewhere, because even if I was going somewhere I didn't know, right? I studied a map before and got familiar with the roads. And if I'm going to that place, I'm going to know something about it. I don't do that anymore. I poke it into the GPS and I do what it says, right? And when doing what it says doesn't work, I'm lost, right? And so I was a better driver before I was assisted by a computer. And then the other bookend to that, your point, the fact is that we're raising a younger generation who will deal with these things better than we do, right? Because they're growing up with that, right? Where we did not. And I think that's a great point. It gives me a little bit of hope anyway, that at least in my old age, my children will be able to help me navigate these things. So that was my comment. It's very interesting. The human factors thing is interesting to me, I guess, because I'm coming to it late. But all of a sudden, there's this whole world opening up to me, going, all these things that I want to learn about, I want to study, I want to understand. I work with people who are very similar to you in their pursuits, right? Cognitive psychologists and college professors. So I've been helping them with studies. I write the code for their studies, and I'm learning a great deal from it. So thank you and all the people who do what you do for teaching me something new.
How many times do you not listen to your GIS and say, I'm going to go take a left anyway?
I do it all the time.
Yeah, I know. I do too. This is over-reliance and under-reliance on automation. And we're going to find that coming in playing as well. But I think one of the challenges we have in data is not just managing the data. I think managing the data is going to be really, really important. But what about analyzing the data? We don't have the mathematical models to do it. We're talking about well beyond 3 dimensions from a mathematical perspective in analyzing this stuff. We have structural equation modeling and things like that, and cause and effects, and we're going to have to be using stuff of that nature. But we need to be talking to the people who are pioneering big data and how they're analyzing it and what's going on with it, because we need to learn from that data that's being collected. Not just that it's great to collect it, but it's awesome to really say, can we learn from it? And I think that's something that's an area that I haven't heard much about.
He's coming. We're back here, and then up to you, sir. Actually, you took the words right out of my mouth. So we hear a lot about data collection and how's data going to get moved from point A to point B, how are we going to do control at these local applications, which is a lot of us in Phoenix Contact what we do. We do a lot of applications with control, transferring data from one place to another, storing that data. But when you think of IoT and what really the whole purpose of IoT is, not just to gather the data, but to then be able to give a user the ability to make a decision based on the data that is collected. But as we increase the amount of data that is collected, I still don't hear enough about how that data is being analyzed to provide us that better information. A user or a person can't do it because there's so much of it. People tend to turn it off because there's too much of it. So I wanted to ask you as panelists, what have been your experiences, or what have you heard through these types of conferences in terms of AI, and what is the future of this data analytics?
I can take a quick stab at that. Yeah, and actually I was going to say this even before your question was, the challenge of, not just managing massive amounts of data, but, also its relationships between data sets, right? And, when Brian spoke about, having flying cars that are, taking 3D, they're taking, map points, they're taking all kinds of measurements and readings, so how do we leverage that data and tie it into some other relationship, whether it's, a set of weather pattern data, right? So, the analytics is super important. It's finding the value and the information and the usefulness of the connectivity of different, wide-ranging data sets, because we're not just talking about transportation. We're talking about, geolocation. We're talking about all kinds of industries that really all have the same requirements and needs that, of getting that kind of information out of their data. And, almost every industry, is plagued by, all kinds of ranges of maturity of technologies. There's old systems, there's new systems. They don't talk to each other, even within the same industry. So, the challenge of, intra-industry or intra-vertical communication is definitely very large. If you talk about the concept of smart city and IoT in general, it's how do we get all of these different industries, whether it's, water supply, energy, building management, traffic flow, cars, people, phones, all of this, right? How, what is that language that everybody can speak together? And one doesn't really exist yet. Maybe analytics is it. Maybe analytics is sort of the thing that ties everything together. It's connectivity, it's connections, it's patterns, it's insight. And those solutions are, being created. Certainly all of the large big data analytics companies, analytics is a science, and Phil's, Professor Grimm, is going for his PhD in analytics. And so, he knows a lot about this stuff, but, we're trying to build a platform that is a universal insight engine, right? Where, all of these different data sets and devices can kind of communicate and talk the same language. So, from our standpoint, we're at least a year out. 2 years probably to get, a fully global system. But, the challenge is there. The need is certainly there. Right now, if you think of data usage, I see it kind of in, the first era or phase one, which is, Facebook takes my data and sells it, right? That to me is the most basic. Getting more sophisticated, then we're starting to look at, okay, well, how can this information be useful to everybody? What are these patterns that can help this system be more efficient, reduce costs, whatever it is. Then phase three is, even automating that whole process, right? With AI and, systems that kind of learn from the patterns and make themselves better. So things are moving fast. I don't think we're there yet on the data side of things. There's really no global data communication protocol yet, but I think it'll happen soon. So.
So I'll take it a little more practical. We're starting to deploy some of this today, and the reason that we're starting to is we build networks. We build networking equipment, and we see that no network can handle all of this. So you mentioned edge devices. There are a number of reasons. One of them is because of latency of the networks themselves and the ability to get real-time safety-critical information from the infrastructure to the vehicle. But a bigger issue is really sort of how do you orchestrate this data in a way that's meaningful? When you buy a vehicle today and you buy an SUV, the Swiss Army knife of vehicles, it's essentially a vanilla vehicle, right? BMW builds every SUV that they sell around the world in South Carolina. So they build them all the same. They ship them all over the world. Yeah, you might have to do left hand, right hand, but primarily it's functionally the same. When you buy an automated vehicle, if you buy an automated vehicle or if your fleet operator gets one for you, it's going to be like your PC was when you first got your PC. And it's going to have to be localized. A lot of the information and knowledge that vehicle needs is specific to where you live and where you drive. And the localization is going to come from your vehicle talking to the infrastructure, whether it's talking to a traffic light, or an RWIS system, or a DMS, or a VMS. And that talking to that infrastructure is going to require DOTs and roadway operators to create microservices. So if this happens, do this, right? So that you can localize this information in your vehicle. The next step back from that, it will happen at a corridor level, meaning if I'm going up and down I-83, this is the data I need for congestion, speed, weather conditions. I used to love to use the Pennsylvania DOT's RWIS site because I had to go over Research Summit. And so if I knew the surface temperature of the road at Research Summit and it started to drizzle, I knew if it was time to get home, right? So that data needs to get into your car at a corridor level. The next level back is the most critical, and that's your traffic management center. Before we get to artificial intelligence, we need machine learning. And we really need a better term for this because it's people teaching machines. The people in the traffic operations center understand the localization and what to do under current situations. We need those people to teach the machines what they should do so they can automate these systems. It's not the other way around. We can't get to artificial intelligence because when we talk about cat videos and training computers to look at cat videos, the first thing we had to do is we had to tell the computer that was a cat, right? There was a human interaction first. The same thing's true with our traffic management systems. So as vehicles become smarter, the infrastructure has to become smarter. And as the infrastructure becomes smarter, we need people in that traffic operations center to take the 7 consoles sitting in front of them and minimize it down because they start to turn those into microservices that can be fed out to the vehicle or to the infrastructure that's going to communicate to the vehicle.
And you can actually use that same strategy. You can actually use that same strategy at a data platform level, where you have microservices that understand different data feeds, what they do, where they go into deep learning algorithms, into Hadoop, into Mongo, into big data stores that then data can be processed. The data analytics side is going to be the breakthrough of everything, and as we continue to look at that, I mean, we're capable of doing 4-dimensional data analytics right now. You look at X, Y, Z plus time. That's just the start, but that's a capability that's there right now in the world of spatial analytics. Where that goes, I probably have ideas, but I'd probably want to keep them kind of close to my chest a little bit because it's probably some intellectual property we'll try to build.
I found this conference to be very enlightening. I've been in technology since 1966, and on the engineering side, on the bleeding edge of technology, and I've personally helped us on this exponential curve. And the shape of the curve today I find to be very, very frightening. Everything we're doing today is based on the cheap transistor. And in 2014, we've been producing 1 trillion CMOS devices, gates, 1 trillion gates every second. Today, I'm sure it must be like 14 to 30 trillion devices. So we've got a lot of switching capability out there. We've got a lot of software which is exponentially growing as well, which is running this hardware. We're storing God knows how much data all along this exponential curve. And we all know that exponential curves don't go on forever. Where do you see the danger in the next 5 years?
I don't think anybody's ever asked me that question.
I know. That's a good question.
I can start it, and yeah, I mean it's that feedback loop of we're using technology to build technology, right? So CAD drawing programs to lay out chips and transistors, everything's getting smaller, so that feedback loop feeds on itself, and thus you get that exponential curve, and yeah, exponential curves are not, something has to give, whether it's right. There's nothing. What's slowing it down? I mean, is it just groups that say, "Oh, be careful of this technology"? And there are. I mean, with respect to artificial intelligence and even just technology in general, there are groups that are talking about ethics, and I mean, even 3 laws of robotics. I mean, there's the modern day version of that, which is how do we even start to put that kind of ethics or logic, or if it's humanness, whatever we want to call it, into the hardware software devices that we're building. And eventually something's going to have to, they talk about the S curve where you've got the flat line of the linear part of the exponential. It hits the exponential, and then something happens, and it kind of, the negative feedback might take it linear a little bit longer, but then it shoots up again. It could be anything. It could be, maybe energy is what is the negative feedback. We get to the point where there's not enough energy resource to handle these types of things. So, I mean, I think it's something that really has not been on the global awareness of humanity for very long. But it's a good thing that we definitely need to understand. And it's great that folks are starting to see it and understand it. Because it's exponential things. They do sneak up on you, right? And as humanity, even if it's not artificial intelligence, even if it's just hyper connectedness or loss of privacy, I mean, there's always dangers and challenges, and as long as it's on the awareness level, we engineers, we can solve these problems as long as we are aware of them and deal with them. So
I think it's just we're in such a strange place that we.
You're the humanist here.
I'm glad I'm human. Oh.
are you?
I don't know. I was contemplating, I think we have enough trouble right now, let alone try to figure 5 years from now. We have a lot of challenges now. So I really, that's why I wasn't grabbing the microphone. I didn't, I was sitting there trying to say, well, what you said 5 years from now, where's it going to blow up or whatever? I don't think it's necessarily going to. I think we've seen a lot of things increase, and we're only measuring certain things as we're watching that curve go up. Those are only certain things, but there's other things that are going up and moving, and things that aren't measured on that curve. And I'm not so sure if we're looking at everything that we need to be looking at. My biggest problem that I have is that we talk about cause and effect all the time, and I don't think that we really look at cause and effect. I don't think we understand exactly what it is, and we don't have the models to be able to look at it. That's why we really want to look at the data and to be able to analyze and learn from it from the human perspective, so we can then plug in what should we do about it. And that's why I believe that that's an area that really needs to be looked at. We can collect tons of data, but what are we doing with it? And I think that's a real serious area to be concerned about. And certainly you're going to run into social issues. And when you run into social issues, then you're just going to have to be dealing with them. We're going to run into money. We're going to run into other things. Someone said to me the other day, this is really great stuff, but who's going to buy all of these cars? We're building something for an elite group of people. Is that true? Well, not necessarily. Maybe the prices are going to come way down. They usually do with technology, et cetera, and people are able to use it. We sit there and say, well, I'm only going to use my car for 4% of the time, so I'm willing to jump in. I'm not necessarily willing to jump in to just anybody's car. The problem has been a social issue. I want to use my car when I want to use it. I want to go to the grocery store when I want to go to the grocery store. I want to go to the restaurant when I want to go to the restaurant. I want to pick the kids up where I want to pick the kids up. Actually, I don't have to worry about that anymore. I got grandkids. So those are things. I don't want to get into a car that's all junked up after somebody else has been into it. So that's an issue. I think another issue we're going to run into is we're going to run into standardization issue. And that's something that really that engineers know very, very much. It should be dear to their heart is standardization. We had to standardize. Remember when it was IBM-like? Remember our computers? IBM-like? How like was it? It wasn't necessarily always very like in IBM, and we didn't have ASCII 2 and so forth and so on. We had to do some standardization, and I think I have a hard enough time going to the airport and getting that rental car and trying to figure it all out. I have a hard time going from Windows into the Mac, if you will, into the Apple, and then back out to Windows again. And it's like, wow. Where's the standardization? There's similarities, but what's the standardization? We have people moving from one system into another system into another system. I think that's going to be a real challenge, and we're going to have to work on that. And standardization is going to come in and be a challenge for innovation.
I'll add one on to this, and I think it is the fact that we, as a profession of engineers and technical people over the years, have devalued the role of mentorship and growing the next generation of professional. And so I think the biggest barrier is going to be the lack of qualified workforce to carry out these complex jobs, because we are not training the next generation of kids, my kids, to do it. We no longer place value on technical vocation training that leads to the workforce that really underpins most of what we're talking about here, right? Because it's not PhD engineers and scientists that go out and integrate things in the field, right? It's the people that come from the regional technical schools, the tradesmen that do that. And we don't have that generation of people ready for today's challenges, let alone the challenges from 5 years. And it's incumbent on all of us, especially us, those of us most, I think, left in the room are private sector, to not allow ourselves to become commoditized so much that we can't afford to employ and mentor that next level of professional. And so mentorship and this disappearance from our industry is probably our greatest threat, in my opinion.
I'm actually going to kind of disagree with Eric a little bit. This will be
And that's all the time we have today. Thank you for coming. Safe driving home.
This will be the first time we've ever disagreed in our lives in the 10 years that we've worked together. That's just a lie. That's what makes us so good together.
That's why it's so fun working at Gannett.
I actually think the thing that's going to implode in the next 5 years will be like socioeconomic issues. I don't think technology is going to slow down. And to go kind of a little bit against what Eric said, you have children that can run iPads and technology better than I can, and I'm a trained, paid professional. These kids don't need the education that we're used to, the typical education that we're used to. They are getting so advanced at such a young age. And by doing that, they're going to drive kind of the technology as it goes. The question's going to be, in the next 15 years, what is a job? What's needed to be done? Can an individual be paid for being an artist full time? I'm a capitalist at heart. I'm not going to get into politics, but you got to think about it a little bit. What a DOT is changes. What a Department of Environmental Protection is, it changes. What our government is has to change in order to keep up with the way technology is going. So if anything's going to slow it down, it's going to be a social uprising or something that's going to cause an issue. That's my opinion. Basically, what I see is, you see college kids, you see high school kids, you see they don't have PII anymore, right? Personal identifiable information. How many people here have taken a selfie in the last 3 days and posted on social media? One. Not that it's a bad thing, but you have there's this upbringing and the way people think now, their identity. I would never dream of saying to somebody that I was in Harrisburg because my wife is at home alone, right? My brain doesn't work that way. I would never say to somebody I'm in Key West, Florida with my wife because my house is at home alone. But that's thrown out. That thought process isn't in a lot of the younger generations. So I don't think technology slows down in the next 5 years. I think there's going to be a social, just a bam.
So we're going to retitle this section "In Search of the Boogeyman."
Yeah.
And Dr. Anderson, I think you pointed it out today, and it sort of struck me when you were talking about the Sputnik program. Sputnik was fear, right? We were fear that they were getting ahead of us and they were going to invade us. And we should have the same fear today, but we're sitting here a little bit too laxed. 5 years was a great time frame, actually, so thank you for that. There's a mechanism in China called central planning. They do 5-year plans. There are 2 5-year plans that you need to know about. First of all, they're building a new internet, and they got Google to yield to build them a search engine that they can suppress. And number 2, they are already going to build automated vehicles as part of that internet. So in the past, and I'm a student of history of transportation, when we talked about competition, it was the Erie Canal against the canals here in Pennsylvania, and then it was the New York Central Railroad against Pennsylvania Railroad. And then we started to compete against Europe when we got into automotive aviation. We're not competing against Europe, we're not competing against Russia. China has billions of people, and they've already decided they're doing this.
End story.
I'm actually not a fear monger type of person. I have a lot of faith, and I got a lot of faith in our community. I have a lot of faith in our what we do in the U.S. and our industries and how we can reach overseas and be working with other people. But we have a brain drain going on in the United States. We are losing. We were the place for people to come for education, and we are not the place for people to come to education anymore. And it's something that has to be really looked at and really taken seriously. And that could be something that could explode for us in this area of the world. And it's a serious issue. And if you start to look at what it is, we just have a drop and a drop and a drop of folks. They're going elsewhere. They're getting their education elsewhere. They grabbed it from here, and it's not always the place to come anymore. And that's going to be a real challenge, because we were the folks that did a lot of invention, even though we weren't able to implement it. We did a whole lot of invention. A lot of folks copied that invention, or we took that, or other people decided to capitalize on that invention, and they went elsewhere to capitalize on it, and then eventually it comes back here. We saw that in the Japanese auto markets. So that I think is something that's a very social issue, and something that we need to be seriously looking at, boosting up. And in Pennsylvania, we need to be pumping some more money into higher ed. We're not doing it compared to what some of the other schools are. You start looking at what it is. It's, even though there's a lot going in, we need to do that, because that's what's going to bring up those people that can then be mentored. Who's my mentoring? Who's my mentoring person? There he is. Yeah. So we need some folks, because education isn't training. That's one thing. Is if people say, "Oh, well, I want to have these darn engineers that you're bringing out." I used to work at Penn State, at the Pennsylvania Transportation Institute. It's like, "Oh, these engineers you're coming out, they're just not even ready to do it." I said, "No, but they're ready to learn, because education is going to teach you to learn. You need to train them." And there's a big difference between training and educating. Training is far closer to mentoring. And so we need to be able to, I think, to do a better job in the higher education world for our students, and in science and engineering, and then mix them up with some of the humanities. I know.
Now, I was on a panel at Villanova University of panel experts in the industry, and the question was asked to me, how can we best prepare our engineering students out in the world? And I said two things. One is teach them how to communicate their ideas, because they could have all the best ideas right here, but if you can't communicate it, it means nothing, right? And the second one is cross collaboration. Work with other departments. Learn to work with departments you're not necessarily comfortable with, but you can learn from each other and learn how to communicate and get your ideas across.
By the way, I'm not against higher education. My wife works at the University of Delaware, and God forbid she gets laid off, because I guess half my income. So please don't think that I'm against higher ed.
No.
Does anyone up there know the death rate on the highways in America?
Is it 38,000? 38, 40,000?
That's the reason for intelligent transportation system, because just that name implies we are not intelligent.
Right.
That's the evidence would suggest that is the human element. Yeah.
Absolutely.
Okay, that's another research topic for a PhD student. So I think I'm not a fear monger either, but just to let everyone know that China has also declared that by 2025, 20% of their vehicles will be EVs, and they have bought rights to lithium and cobalt mines already in Africa. While we are worried about brain drain, they are going around the world. They're building infrastructure, supporting the government's building infrastructure, building the Silk Route again. So no fear mongering here. So with that, I'm so sad to say that we have to bring this informative and enlightening and such an exciting session and such a thought-provoking session to an end. I want to thank everyone for being so participating here in this event, asking questions, so engaged. I think we had a very lively audience today. I also want to thank the panel, the presenters. I think you made it look a very, very good event, and I think it was informative for me. It was mind-boggling for me, and I'm sure you all found it very informative also.